And just as with C++ and Java, C# is a strongly typed, or if you prefer, statically typed language. So in C#, the type of things like method return values, method arguments, and local variables must be declared in code. While fans of loosely typed languages find strongly typed languages somewhat cumbersome to work with, the effort pays off with the prevention of errors at both compile time and runtime, which is a significant benefit, and one we'll revisit shortly. That said, the C# compiler is very often able to infer the type of a variable or parameter by analyzing the context of its usage. In this case, the type of variable n can be unambiguously inferred to be the same as the type of the length property of the arg's parameter, which in this case is an int. In C#, developers signal that they want the compiler to infer the type of something by using the var keyword instead of specifying a concrete type. So long as there is nothing ambiguous about a type inference expression, the C# compiler will substitute the concrete type, int in this case, when it compiles your code. If we open this code in Visual Studio, we can verify that the compiler is correctly inferring the type of n as expected a couple of ways. First, if we hover over args.length, Visual Studio tells us that property is an int. And if we hover over n, we can see that Visual Studio has correctly concluded that n should be an int as well. Secondly, we can confirm that type information is made available at runtime by inspecting things in the debugger. To do that, I'll run to the point where the for loop begins, and then use the debugger's intermediate window to evaluate some of the type information that's available at runtime. For example, calling getType on the length property of the args array, and then evaluating its full name property, confirms that args.length is technically an instance of the standard system.int32 type. Doing the same for the loop variable n confirms that it's also an instance of the system.int32 type. Now, in this program, the coding convenience we just achieved is literally a wash, since int and var both involve typing exactly 3 letters. But type inference pays much bigger dividends when working with custom types, especially when working with something called generics, which is a subject for another course in the library. You'll also see more examples of type inference in just a moment and throughout the course. The fact that this kind of type information is available at runtime, not just compile time, is what makes the next key feature of C# possible.